Hello, everybody. I'm Silas, and welcome to Psilocybology. Let's expand our mind. This is a series where we talk about the research on psilocybin, the psychedelic prodrug found in magic mushrooms. We'll be breaking down and discussing the scientific literature, one study at a time, from past to present. If you'd like to support the show, please make sure to rate, review, and subscribe to the podcast. I want to start off today's episode with a few updates. First off, thank you to everyone who provided feedback for the podcast through the listener survey that was sent out. Reading the comments you all left was incredibly meaningful, so thank you. After looking through the results, the first announcement I want to make is that the majority of responders selected Monday as their first choice release date for new podcast episodes. So it is written, so it shall be done. The new episodes will air on Mondays, starting today. Apologies if you hadn't heard about the schedule change until just now. But for the future, if you'd like to make sure to stay up to date on news about the podcast, you can always subscribe to the mailing list through the website at psilocybology.org. You can also follow the podcast on Twitter at psilocybology. The second announcement I want to make is that the winner of the $100 donation is MAPS, the Multidisciplinary Association for Psychedelic Studies. The donation has been submitted in honor of all of us, the listeners of the podcast. The last update I want to give before getting into the article for today is that in psilocybin-related news, Denver City residents will officially be voting this May on whether the use and possession of psilocybin-containing mushrooms should be decriminalized. I want to emphasize that this initiative is for the decriminalization of psilocybin and not the legalization of psilocybin. What this means is that, if passed, it would, quote, prohibit the city of Denver from spending resources to impose criminal penalties for the personal use and personal possession of psilocybin mushrooms by individuals 21 years of age or older. Importantly, it does not legalize magic mushrooms. It would still be classified as an illegal drug, and it does not allow for the buying or selling of mushrooms, which could still be prosecuted. It's very similar to sanctuary city ordinances, which typically prohibits a city from using city resources to assist Immigration and Customs Enforcement, or ICE, in deportation. The argument in favor of this initiative is first and foremost that people shouldn't be going to jail for using something that is proven to be safe, that literally grows naturally in places all over the world, and that has been used by humans for thousands of years. This initiative is about not spending public tax dollars on prosecuting and jailing people for doing something that researchers paid students to do in the 60s. Now, given that, there are absolutely some valid criticisms to this initiative. For example, since this is only for the decriminalization and not the legalization of psilocybin, this means that psilocybin wouldn't be regulated, and thus the sale and distribution would be kept on the black market. Another point that others have argued is that this is too much of a piecemeal approach to drug policy reform, and that we should be pushing for the decriminalization of all drugs at once. Some have also pointed out that psilocybin is stereotypically thought of as a drug used primarily by white people, and thus this initiative doesn't fully address the disproportionate harm current drug policy has on people of color. Those are all incredibly important points of discussion, but they can only be raised when we first properly understand what this initiative is and is not doing. And quickly to respond to some of those criticisms, I'd argue that given the wave of emerging research into psychedelics, public opinion is shifting, and it is providing a unique opportunity to make meaningful progress in drug policy reform. I think with the current climate, we are able to push through decriminalization efforts for psychedelics that we might not necessarily be able to pass as easily for drugs like heroin. Take all of the pushback right now for safe injection sites as an example, despite the overwhelming evidence in favor of them. I can't even imagine the headlines that would follow an initiative to decriminalize an opioid right now. I don't think that at all means we shouldn't be fighting for safe injection sites or the decriminalization of all drugs, including heroin. But I also think that we should seize on the positive media portrayal of psychedelics while we have it, because it may further influence public opinion about drug policy in general. Yes, it is just a small step. But voting yes on decriminalization will continue to promote vital conversations around drug policy that does go beyond just psilocybin. It also allows us to show others that drug policy reform does not bring about the end of civilization. There are people who legitimately fear that drug policy reform, despite the fact that it is evidence-based, is going to lead to mass hysteria. What isn't talked about as much with this initiative in Denver, although it should be, is that in addition to decriminalization, it also sets up a special counsel that will collect data and report on the effects of the ordinance. As I discussed with a friend of mine, unfortunately, many Americans often only trust data that comes out of America. They don't care if other countries, like Portugal, for example, have proven how effective decriminalization is, because many individuals have been indoctrinated into the cult that is American exceptionalism. If we can show people that, even in America, decriminalization works, then maybe we can use that as a foot in the door to continue pushing for further drug policy reform. Anyway, apologies for spending so much time of this episode on that, but I think it's really important. Plus, some of you did indicate an interest in hearing more about psilocybin-related news in the biannual listener survey. So although I won't do this every episode, every so often I will probably spend a couple of minutes discussing this type of content. I think it also works well on episodes like today's, because as you'll see, the article for today is pretty easy to digest, and I don't anticipate it will take a long time to talk about. And on that note, let's dive into the article. Today's episode is on the study titled Lysergic Acid Diethylamide, Comparison with Effect of Psilocybin on the Siamese Fighting Fish, published in 1963. This to me was a somewhat interesting experiment. I'm never a huge fan of animal studies, for reasons I've discussed in earlier episodes, but I do at least appreciate that in this case, similar to the spider study discussed on episode 11, the fish didn't have to be killed off to do the experiment. The researchers simply administered either LSD or psilocybin to a bunch of fish, literally hundreds, and watched their behavior. The reason these researchers chose to compare LSD and psilocybin is because prior studies showed when you put Siamese fighting fish in solutions of LSD, that is, LSD dissolved in water, they exhibit a pattern of behavior that was characterized as semi-quiescent, meaning they appear to be more inactive and lethargic. This is very similar to the results of the spider study I mentioned earlier, where spiders given psilocybin spent far less time web building. Given this finding for LSD, the researchers wanted to see if the same was true for psilocybin. The researchers also designed the study to test out a novel technique for injecting small volumes of liquid without using anesthesia into the body cavity of fish. This is something that apparently was recently developed, and it allows them to compare what is sort of the equivalent of orally administered drugs and drugs administered via injection. Specifically, in this case, intraperitoneal injection, which is the scientific term for injection into the body cavity, as opposed to something like intravenous or intramuscular injection, meaning the injection into the veins or muscle tissue, respectively. What's key for this new technique is that Siamese fighting fish are actually able to breathe air, so they can be kept outside of water for several minutes without injury, allowing the researchers to administer the drugs. Ignoring for a moment the various doses they tested for each drug, there were essentially 5 experimental conditions. 2 conditions involved administering LSD, either by dissolving LSD in their tank water or administering it via injection. 2 other conditions administered psilocybin, again, either by dissolving psilocybin in the tank water or administering via injection. Now, in reality, these 4 conditions were actually split further, depending on the dose administered, which we'll discuss when we get to the results. Regardless, the final condition was a control condition, where fish just swam around in normal water. I will say that it would have been ideal to have another control condition, where they injected saline into the fish. That way they could make sure the process of injecting the fish didn't itself alter their behavior. That said, it seems unlikely to me that it had a large impact, since, as we will see, the behavior of fish administered LSD, either via the tank water or injection, acted very similarly. So the results section of this paper is split into two sections, with the first half focusing specifically on LSD and is aimed at examining the differences produced by route of administration. For the first condition, researchers placed fish in tanks that contained 3 varying concentrations of LSD, either 0.1 micrograms per milliliter, 0.5 micrograms per milliliter, or 1 microgram per milliliter. For the control condition, again, it was just water. What they found was a really nice dose-response relationship, where the higher the concentration of LSD, the greater percentage of the fish began to exhibit the so-called semi-quiescent behavior. The percentage of fish that responded to LSD also increased the longer they were swimming in the tank, leveling off after about 3 to 4 hours. Notably, for the 1 microgram per milliliter concentration, nearly 100% of fish responded, whereas the maximal response rate for the 0.1 microgram per milliliter concentration was a bit under 80%. Now, for the entire study, that was the primary outcome, the percentage of fish whose behavior changed as a reaction to the drug administration. In particular, I'll note that they were looking for behaviors that included floating at a 40-degree angle near the surface of the tank, for backward swimming, rolling along their axis, and displaying their fins. These were all the behaviors that the researchers recorded during their first preliminary experiments with LSD. So now let's compare the response to LSD dissolved in tank water to LSD administered via injection. For the injections, fish were either given 0.01 micrograms of LSD, 0.05 micrograms of LSD, or 0.1 micrograms of LSD. The first observations the researchers noted is that, as expected, fish react to a much smaller amount of LSD when they are injected with it than when they're just swimming around in a solution of it. More interesting, though, is that when it's injected, they can actually see the time course of the drug. What they found was that, for all 3 doses, the greatest percentage of fish began exhibiting the semi-quiescent behavior between 1 to 2 hours after injection. After it peaked, the percentage of fish exhibiting the behavior pattern began to decrease and leveled off back to baseline between 4 to 8 hours post-administration. What was remarkable to me in reading this is that the time course found in this study isn't wildly far off from the time course we see in humans. Now, the second half of the results is where we examine psilocybin. The first really notable finding is actually the absence of results. Specifically, that when the researchers tried dissolving psilocybin in the tanks, none of the fish exhibited an altered behavioral pattern, even when the concentration was as high as 100 micrograms per milliliter. The researchers have no idea, or at least didn't disclose any idea, as to why this was the case. Psilocybin is water-soluble, hence the popularity of psilocybin tea, so I'm surprised myself that it didn't work. If anyone has any ideas, please do let me know, and I can bring it up again in a future episode. My one theory is that it has to do with membrane permeability. So, for example, let's think about the blood-brain barrier. The blood-brain barrier in humans prevents certain chemicals from entering the brain. Data has indicated that while LSD easily passes through the blood-brain barrier, psilocybin, as we've talked about on some earlier episodes, does not. Psilocybin is first converted into psilocin, in a process we talked about in detail on episode 9, which then readily enters the brain. My hypothesis would be that fish gills, somehow, have a similar permeability filter that for some reason readily allows for the passage of LSD, but blocks psilocybin. Again, this is just a theory, and I have no idea how accurate this might be. An interesting way to test it would be to compare how fish respond in a tank containing psilocybin to a tank containing psilocin. Not sure if there are any Siamese Fighting Fish researchers listening to the podcast right now, but if you're out there and want to try and test this, make sure you mention the podcast in your paper. Getting back to the final and arguably seminal set of results, the researchers injected fish with either 2.5 micrograms, 12.5 micrograms, or 25 micrograms of psilocybin into the Siamese fighting fish, and found the characteristic semi-quiescent pattern of behavior in response to all 3 doses. The researchers noted that the most comparable doses between the 2 drugs was 2.5 micrograms of psilocybin and 0.01 micrograms of LSD, which produced a response of both similar magnitude and duration. I'll put the figure in the episode transcript for anyone who wants to see it, and if I remember, I'll add it to the Instagram as well. Actually, speaking of which, let me know if tables and figures are something you'd like to see on Instagram. Right now, I've mostly been using it for promotional images, but would be happy to use it as a place to post figures. Anyway, based on the observed patterns of behavior after both LSD and psilocybin injection, the authors conclude that these near-identical patterns and time course indicate that they likely rely on the same enzyme systems to be broken down. Now, this is actually a pretty bold claim, especially because even today, we know far less about how LSD is metabolized than we do for psilocybin. I'm also personally not certain that the conclusion in this case can really be drawn from the premises or the results. Because, for example, it's possible that there are 2 separate enzyme systems that simply break down these drugs at a similar rate. Nevertheless, the data is interesting, and at the very least, thought-provoking. Well, that's it for today's episode. As always, I really hope you enjoyed the show. If you have any questions, feedback, or ideas for the podcast, please let me know. On that note, there is a new email for the podcast. You can now reach me by emailing silas@psilocybology.org. You can find out all of the other ways to reach me by going to the website, psilocybology.org, where you can also find the full transcript for each episode if interested. Thank you all for listening, and I'll talk to you next time.